everybody. Okay, so welcome to Contaminant Hydro. Woo. Okay, so today I'm going to be using mostly the board here to be writing on and doing some organic chemistry. So you guys are going to be seeing me drawing on here because these are benzene rings. And I was working here with Madison to figure out what colors work, and so that's what all this is down here. It's like we were checking out all my different crayons because, you know, crayons work really well for this kind of stuff, so we were checking out all the different sizes and everything. So just so you know what we're doing today, just keep in mind that Friday we have our Zoom, and it's all synchronous. So everybody has to be there, and everybody has to be on Zoom. The Zoom login thing is online. It's on the syllabus. I'll send it probably out before the class. So everyone will be online on that day, okay? Just so you know that. And the other thing that you need to do is there is a homework assignment, so make sure you look under in Blackboard, go to for the class on Friday, that date, and if you look inside of that folder, it's got the reading and the homework assignment for Friday. So make sure you do that before Friday, and I'll probably send out an email or something like that since class is done here. Just so you know, that's what we're going to be doing. Okay, so that's the updates on what we're going to be doing on Friday. So look inside of there. Okay, so what we're going to be doing today is organic chem. Now, I should be able to figure out how to do this using a PowerPoint, but I don't know how. And honestly, this works out great because then you guys will be writing along with me, so there is no slides today. So why do we care about organic chemistry? Why do I start this class off with organic chem? Well, there's a couple reasons. One, geology majors don't get chem, don't get organic chem class. So that's one of the downsides, I think, of, one of the downsides, I think, of the geology, the way we teach it, is that you never get organic chemistry. You get one semester or 1 year of chemistry, and you really do need a basic organic chem class in order to be able to understand the two main contaminants that we're going to be talking about. One of them is BTEX compounds or gasoline. So we'll go over what BTEX stands for here in a second, but if I say BTEX, I'm really referring to gasoline spills and stuff like that. We'll go into isooctane, and you're going to know a lot about it. So this is probably one of the largest contaminants there is in groundwater systems is gasoline spills. Why is that? Well, there's a gas station on every corner. They have the leaking underground storage tanks. People change their oil in their cars at their home. You know, we just had a major oil spill that happened off, in the oceans. So oil and gasoline are big. The other thing that with gasoline too is, where do a lot of geologists get jobs? Well, they work in the oil and gas fields. So this is gasoline and oil are really the big important parts of this. Okay, so reason why that those are really important is because, this is the field that you guys are going to go into. So you guys should actually know something about gasoline and oil. The other big contaminant is TCE, or trichloroethylene. TCE, and there's a whole bunch of compounds that kind of fall within this. These are chlorinated hydrocarbons. These are your Dean apples that we talked about last time. These were spilled a lot because, better living through chemistry, so we were finding all these chemical things that we could put. We're going to be talking about PFAS here in a short time. And we start talking about PFAS, it's everywhere, and things like that. And so these are all organic compounds. So the main contaminants that a lot of gasoline spills to major organic compounds that you're going to be cleaning up and doing work with are organic in nature. And since you guys never take an organic chem class, it's kind of my duty for you guys to learn organic chemistry so that you guys can talk about this. The third reason for this is understanding organic chem. So once you know organic chem, you can understand the fate and transport. So if you don't understand organic chemistry, like what the molecules look like, properties of them and stuff like that, you will never understand the fate and transport of these compounds. So you really need to understand how the molecules work, what the basic chemistry is of them, so that we can do the fate and transport. I use the word fate and transport a lot as kind of describing my research because we're talking about the fate of it. So how does, does it biodegrade? Does it absorb? If you guys remember, this is absorption, biodegradation, any sort of natural attenuation, so where it goes away. So what happens to it, and then the transport is how fast does it move. So we're going to be talking about those types of things, fate and transport of the compounds. So I like to start off with organic chemistry because then once you understand these things, then we can get into the advection dispersion equation and start talking about all the different chemicals. So you already, I'm assuming everybody had taken a basic chemistry class, so I don't have to teach that. So I teach this instead. Okay. Okay. So one of the things that I'm going to go over today. Okay, so what is organic chem? Well, basically, we're going to start off with there. Just want to see where I want to start. Okay, so what is an organic molecule? So Madison is here. What is an organic molecule? Or an organic, when we're talking about organic, what are we talking about here? Carbon. Okay, so it contains carbon. That's it. So what about calcium carbonate? What's the molecular formula for calcium carbonate? It's got carbon. Is that an organic compound? So it has carbon. Is methane an organic compound? Yes, this is methane. This is an organic compound. So that only has one carbon. Then it's the carbon and hydrogen. So we got carbon and hydrogen. Okay. Yeah. So usually it's carbon and hydrogen bonds mixed together. So good. So we have carbon and hydrogen in there. A lot of times we'll also have oxygen. Sometimes we'll have other compounds like nitrogen, sulfurs, and stuff like that. But basically, it's things with carbon and hydrogen into it. So methane is an organic compound, while calcium carbonate is not. So it's not just the presence of carbon inside of it, it's also the presence of the hydrogen that's in there and that carbon-hydrogen bond that we find inside of there. So we can get compounds like that are triple bonded, so it's just this. That is an organic compound. So these are the 3 triple bonds between 2 carbons. It's still an organic molecule. Okay. So, and then this is ethylene, I think. I'm trying to remember it, because we never use this, and we'll never see this as an organic compound in nature. Okay, so organic compounds, as we mentioned here, are always contain carbon and a limited number of other compounds. So they'll contain carbon, oxygen, nitrogen, sometimes sulfur, sometimes what the compounds called halogens. Halogens are that, those are the compounds like fluoride, chlorine, iodine, bromine. Those are the halogens, okay? So an example of it is, we could go with C6H12O6, and this is glucose. So the basic sugar compound used for your body. So this is your basic compounds in here. So organics contain this carbon bond. And if you guys remember, carbon has 4 bonding sites associated with it. You should remember that from your basic chemistry. And so what hooks onto these 4 bonds can be a lot of different things. Okay, so we're going to be talking about that. And then things like nitrogen have 3 bonding sites, oxygen have 2, and then all your halogens have 1 bonding site, okay? So what you can do is, like if you think about it, so you can put 4 things on here, you can attach 3 things on here, 2 things on here, and this can only attach 1. So if we look at a compound, we can put a carbon, we could put a bromine on there. Well, we still have 4 spots that we can put something, so we can put a nitrogen. Well, nitrogen uses 1, so it's got 2 more that we can put onto there. So we could put hydrogens if we'd like. And hydrogen only has 1. And then we can put an oxygen over here. Well, it's still got 1 that's open, so we can put a hydrogen there. And then, so you can see how, knowing this, that this has 4, this has 3, this has 2, and these have 1, make it so that you can put things together. And then wherever it's empty, so like if you don't put one of these other compounds on there, we throw in a hydrogen. So hydrogen gets thrown in everywhere. So we just kind of throw that wherever we have open spots. We usually never write the hydrogen because it's just assumed to be in all of this. Okay? So these are the basics of organic chemistry. Now, carbon can form, like here, we're forming them single bonds. Carbon can go 1 bond to another carbon. It can do 2 bonds to another carbon, and it can do 3 bonds to another carbon. Okay? And when you have that, so then if you have this 1 bond, then you have these spots open. Here, if you have 2 here, then you have 2 on each one of these. And then if you have 3 here, you have 1. So you go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. They can share those bonds. So this is 1, 2, 3, 4, 1, 2, 3, 4. So both of them have 4. So carbon will either have single bonds, double bonds, or triple bonds. Okay, so you can get any one of those combinations when it comes to carbon. And we're going to be talking a lot about these different ones that are in there. Okay. The other weird thing with carbon, too, is it can form, like with benzene. So this is benzene. What it does is, let me start doing that again. Benzene can be a carbon, carbon. Let me start again. A sheet of paper here. So we're going to do benzene real quick. So carbon. There we go. 1, 2, 3, 4, 5, 6. Okay, so it's 6 carbons and they form a ring. So we can put a single bond between each one. Okay. And then we can put a hydrogen, and there's 1 hydrogen per each one of these. So what's missing? The 4th, yeah, because this one has 1, 2, 3, this one has 1, 2, 3, 1, 2, 3. So where do we put that 4th bond? On here. Well, yeah, so basically what ends up happening is it shares that double bond between all of them. So it kind of goes into the center. So we can draw this 2 different ways. We can either do it every other one has a double bond. So now it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All these have 4s. And so we could do double, single, double, single, double, single. But that's actually not really what's going on when it comes to benzene. It shares it as a cloud. And so the way we usually draw benzene is we draw a circle in the middle. Okay, so this is benzene. It's got that circle in the middle because that represents that that double bond is being shared amongst all of the carbons that are on here. Okay, so this is not the same as that, where we have 2 hydrogens per each one of these. I'm just drawing them out. Usually you don't even draw these little guys, but I'm just doing it for demonstration purposes. Okay, so here's a carbon, 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 and here's a carbon. These 2 things are not the same. Because now this one has 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, but they have 2 hydrogens, and all of them are single bonded. This is cyclohexane. So cyclo meaning circle, hex meaning 6, ane meaning single bond. So single bond, cyclo meaning circle. Okay. We're going to go a lot into this shortly, and so this will all make a lot more sense very soon. But I just wanted to go into this idea of single and double bonds, that these 2 things are not the same, that this is benzene, and this is cyclohexane. And this has single bonds, this has single and double bonds, okay? Benzene is probably one of our main contaminants, and when we talk about contaminant hydro, it is one of our poster childs for everything. So when gasoline spills out, this is the most soluble part of the gasoline is benzene. So it'll be the first thing when you spill gasoline that when it mixes with water will come out. It's also the most known carcinogen, so it causes cancer. It's very, very soluble, and the MCL is very low. I'll have to look up the MCL. I believe the MCL is 5 ppb. I'll have to look that up to remind myself. But it's a very low MCL compared to its solubility, and so this becomes one of our main compounds that we're going to be spending a lot of time doing. So make sure you understand how to draw it and what this compound is. We're going to be coming back to it a lot over the next couple days and weeks and stuff like that. So you will learn a lot more about this, okay? Compounds, organic compounds can be, organic compounds can also be polar, and they can be non-polar. So what does that mean to be polar versus non-polar? So non-polar compounds are things like benzene here. Polar compounds, you guys remember, that's where when something is polar, it has a positive and a negative charge to the edges of the compound. So something like CH double bond O here. Notice that you can do a carbon with a double bond to an oxygen too, because oxygen needs the 2 bonds, and so it can double bond straight to a carbon. What will happen here is this will be positive and this will be a slightly more negative compound, okay? And so you can get these polarizations of compounds, and the nonpolar is like our benzene here, where there is not this slight bit of negativity over here and a slight bit of positivity over here. This becomes really important when we start talking about things like surfactants. Oh, I can't spell right now. Surfactants. Surfactants. What is surfactants? Surface active agents. So when you wash your hands and you have soap, what it is the molecule in there, half of it is polar, half of it is nonpolar. Okay, so water, is water polar or nonpolar? Polar, right. So this is water is polar. Okay. Oil, is oil polar or nonpolar? Oil. Oil and gas, does it mix with water?
Oh,
no. No, so this is oil. Okay. So oil is generally nonpolar, water is polar. Well, this is why oil and water don't mix, is because polar compounds, like dissolves like, you can't mix these two together because polar compounds, oils and stuff like that, will dissolve with nonpolar compounds. Polar compounds will dissolve here. So if you have a surface active reagent or soap, what that does is it's got a nonpolar end and a polar side. So what it does is it's got this long organic molecule that hooks to the oil, and then it's got this, so you've got your water molecule over here. It's got a charge on this end to connect it to a water molecule. So basically it combines your water with your oil together, and then it sticks them together. So one side sticks the oil, one side sticks the water, and then you can remove the soap from there, because an organic molecule can have a polar and a nonpolar end. They can be completely nonpolar, or they can be completely polar. Okay? So if you don't remember polar versus nonpolar from basic chemistry, I would re-look this back up, make sure you understand the chemistry behind polar versus nonpolar in here. But I just wanted to go into that. Organic molecules can be polar and they can be nonpolar. So if they're polar compounds, they mix really well with water. What is an organic compound that mixes really 100% with water? You probably have used it every single day. We're using it a lot lately. If you've been home a lot lately, you've probably been consuming this a lot. Is ethanol. Ethanol right here is a polar compound because it mixes 100% with water, right? You know, you have your alcohol. You can have any percentage or proof of alcohol in your compound because it mixes 100% with water because it's a polar compound, okay? Versus oil, if you guys are making a lot of salads and stuff like that, you're going to be putting a lot of oil into it, which is a nonpolar compound. And then how do you mix these two together? You put soap, or there's surfactant, your surface active reagent, okay? So that just gives you kind of an idea of So we have polar, nonpolar, and the structures of the compounds. Okay. Here. Okay. Okay. So when we start talking about organic compounds, what we're going to be doing is we're going to be looking at carbon. Like, Madison said, it's carbon. It's not just carbon because, if we just say carbon, then we're referring to a lot of other compounds too. But what we're going to be talking about is all the different functional groups that fit into organic compounds. So we're going to start off with the basic ones and move our way up, and then we're going to talk about how you name compounds inside of here. Okay, so if we have one carbon, if we have alkanes, what is an alkane? An alkane means all single bonds. So it's a carbon single bonded to another carbon. So this is the functional group. Okay, this is the name of it, or the class of the compound. It's called an alkane. It means it only has a single bond into it. An example of it would be C bonded to C. Now, what am I missing on here? Well, all those little hydrogens, right? Because you have to have 4. Or you could just draw C-C, and you just assume all the carbons are there. Okay. And then when we name these compounds, we end it with the letters A and E. So it ends with A and E. So when we have one carbon, side note over here, I'm going to come back to this sheet here in a second. So if we have one carbon molecule, this is called meth. Okay? If they're all single bonded to each other, so meth is one carbon. If they're single bonded, you end with A and E. Methane. So that would be just this. And you can't do anything more with methane, is 1. Okay? If you have 2 carbons, molecules, that's F. So that if you have them bonded, single bonded to each other like we showed before, and you have single bonded, it'll be ethane. So it ends with ane. If we go with 3 carbons, we have the word prop. And if all 3 carbons are single bonded, it is propane. Yes. If we have 4 carbons, it's bute. So if they're all single bonded to each other, it's butane. Yes. It's very simple. So this last word here is this part here where I'm going to be going into these functional groups, where we add that ane at the end. So butane means that they're all single bonded. If there's 5 carbons, it's pent, and if they're all single bonded, it's pentane. If it's 6 carbons, it's hex. 7 is hep. 8 is oct. 9 is none. And 10 is dec. Okay? So if something has a single bond, it ends with A-N-E, and then you count up how many carbons are in the longest chain, and we'll get to this in a second, but wherever the longest chain of carbon is in your molecule, it has these names. So you guys have probably heard of propane. What's propane used for? Where have you heard of propane? Cooking, yeah. This is what you guys cook with gas. You know, when you guys are out in the grill, what's in the grill? It's propane, right? If you go camping and stuff like using propane. So what does the molecule look like for propane? Well, it's 3 carbons long, so it's 1, 2, 3. It ends with the letters A and E, so we know it's a single bond because that's what this means. If it ends with A and E, it means it has single bonds. So the carbons are single bonded to each other. And then we have hydrogens in all the other spots because we have 4 spots for each carbon, so we put hydrogens in. Now, if you notice, it's a really pain for me to draw these little hydrogens. So we usually don't draw the little hydrogens in. We just usually can do this. But even simpler, we can just go like this. Because this is called the line drawing for it. And so this represents a carbon, this represents a carbon, and this represents a carbon. And then we just assume that there's hydrogens associated with all of these. Okay? Or you could just draw 3 carbons with the lines between them. All of these things are correct. You can draw the little hydrogens, you can just draw the carbon, or you can just draw the line. So we all know what propane is. What about butane? Where have you guys heard butane before? If any of you guys are smokers? Butane lighters. Butane lighters, it's a very common thing for use for lighting something. So it would be 4 carbons, is butane. Okay. What about any of these others? End with ane that sound familiar to you? Know any of these other ones? Pentane, hexane, heptane, octane, nonane, or decane? Any of those sound familiar? Octane. Okay, yeah, we talk about octane. Where do we hear about octane? Where do we usually use the word octane at? Yeah, it's an explosive, but you probably saw the word if you had today. If you drove a lot and you needed to put something in your car, what did you put in your car this morning? Yeah. What number did you pick? But what is that number?
Oh, the octane.
Ah, yeah. Remember, so when you pick the numbers, there's the 87 and the 94, and it says octane.
I don't look at those.
Yeah, but
they're there.
Yeah, you know the octane rating. You know that's what that numbers mean. Yeah, and you see the word octane on there. Yeah, so that's octane. So octane means that it's got 8 carbons and they're single bonded. In reality, that is not true. What it is it just means that it is, well, it is true. What it is that as that number goes up, it's more explosive, as you mentioned. So it increases the explosions when the piston goes up and down. So what happens is as you ignite something inside of your engine, it gives it more and more power. So the higher the number, like jet fuel and stuff like that, will have a higher number in there. So what does that actually mean is that the actual, like, to make it, we'll get into this a little bit more for octane ratings. Once I go into a little bit more chemistry, we'll come back to octane and show you why it's actually not just 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8 carbons long. It's actually more than that. It's more than just this. But we use the word octane to refer to gasoline. So we'll come back to that one once we get a little bit deeper into this. But you do need to memorize these, and you should know these off the top of your head: the meth, eth, propyl, butyl, pent, hex, hep, octanon, dec. You should know 1 through 10 off the top of your head. Okay, so these you should know for exams and for just basic chemistry knowledge. So this becomes really important when we start talking about organic compounds. Okay, so we'll come back to octane in a little bit, but right now you need to know those. Okay, so let's go back to this. Okay, so we have alkanes, single bond C. It looks like this, this, and this. And then if you had 4 carbons, you know, we can go back to this sheet here and say, oh, okay, 4 is butane. Now the next one on our list here is alkenes. Okay, this is where the functional group is C bonded to a C, double bonded. Okay, so if we put here, we put C double bond C. Okay, these end with E-N-E. So what would this compound be called? Well, what we do is we count the longest chain of carbon first. So the longest chain of carbon here is 2. We look at our sheet and we go, okay, the longest thing of carbon with 2 has this as the prefix. So this is F. And then we end it with E-N-E. So ethene. Now this is just a weird quirk of things. Ethylene, putting this little group in here. Ethylene is also the same compound. Okay, and we'll come back to this YL in here in a little bit. Okay, but for right now, these two are the same thing. So you count up the number of carbons. That becomes the first part of the word, and then the last part of the word is the functional group, and in this case, a functional group is 2 bonds together. Next one is alkene. C triple bond C. So remember we went single bond, double bond, triple bond in here. That's the functional group. So if I drew this compound here, an example would be like C triple bonded C to it. We have a hydrogen on this side. And let's hook this up to another CH3. Okay? So this carbon here has 1, 2, 3, 4. This one has 1, 2, 3, 4. This carbon comes over here as 1 and then has this 3 hydrogens hooked onto it. So we usually write it that way. What you would usually write this as CH3 dash C triple bond C and put the H over there. Okay? So that's written the same way. I wrote the hydrogens on this side to represent the hydrogens would be on the outside, but the hydrogens are really just, we usually write CH3 right there. The ending of these is YNE. So what's the longest chain of carbon on here? So is it 2 or 3 carbons long? 3, yep, so it's 3 carbons. So 3 carbons, it has prop. So this starts off with the word prop. And then we end it with YNE. So here's our suffix, tells us that it's a triple bond is our functional group. And this first part tells us the longest carbon. Okay? That is the basics of all of this. It is the last letters are the functional group. And then the first part of it tells us the longest carbon chain. Okay. The next one on our list is alcohols, which you guys all know. And the functional group there is COH. It means it has this OH group connected to a carbon. That's what an alcohol is. Now if I write CH3, CH2OH, that's the example. It ends with OL. So what's the longest carbon on here? 2. 2 means ethyl, F. So this is F. And you end it with F on all. So it ends with all, starts with F for the longest carbon. So if this had 3 carbons into it, it would be propanol. If it had 4 carbons, it would be butanol. So you end it with this all means that it's got this carbon and a hydrogen into it. And you put how long the carbon is. So that's an alcohol group.
Can we just add the extra little couple letters to make it sound better?
Yeah, because you can put ethol. Ethol wouldn't sound right. And so ethanol, ethanol. So this is ethanol. Yeah. In the lab, you'll see this abbreviated that a lot. If you see this in a laboratory, this stands for ethanol. So ETOH, they'll put this on bottles and stuff like that, referring to ethanol. And I think one of the reasons we do that is, like, if you wrote the word ethanol or you wrote the word alcohol on something, what's going to happen to it? A lot of people might think, oh, I'll drink it. You know, this is something I can drink. Well, not all alcohols are drinkable, trust me. So this is ethanol, what we consume, okay? And so we put ETTOH so that someone knows it's an alcohol group, and then we know it's ethanol, and then it's an abbreviation, and then no one knows really what's inside of it. So this is why we usually use this. So this compound, and we're talking about alcohol for a second, if it's got the 2 carbons, it gives you a nice buzz. What happens if I had this? What's this compound called? Methanol, yep. This is methanol, because it's, again, it's an OH group at the end, so it's this. It's got 1 carbon, meth. So the difference between ethanol and methanol, ethanol will give you a buzz. What happens if you consumed methanol? You guys know what happens to you? You get headaches, you can go blind. So when you have bad alcohol and you get a really, really, really bad headache, it could be have a little bit of methanol into it. Even with the hand sanitizers recently, what's happened with the hand sanitizers is some of the cheap ones that are coming from other countries and stuff, it's supposed to be just ethanol, but what's happening is because when you have the conversion over, some of the alcohol doesn't all just become ethanol, some of it becomes methanol, and that methanol is getting into hand sanitizers, and then people put it on their skin so much that it's absorbing through their skin, and it's causing them to get nauseous, sick, potentially go blind, and everything like that. So that 1 carbon molecule in here, this can kill you. This gives you a nice buzz. And it's just 1 carbon difference. Okay, and they're both an alcohol. One is methanol, one is ethanol in there. We can also refer to this, just to make things even confused. So part of the problem with organic chemistry is that I'm teaching you guys this, but there is a million different names for this 1 compound. As I mentioned, we call it ethanol. We can also call it ethyl alcohol. So ethyl alcohol. Now, if you see this little YL here, that means, and you saw it up here too, this little YL, it means that it's a 2 carbons stuck onto our functional group, which is an alcohol here. So you can also write it as ethanol. You can write it as ethyl alcohol, or you can also write it as ethanol. So it's ethyl alcohol, ethanol, ethyl alcohol, or ethanol are all exactly the same thing. And we're going to probably not get into it today, but we'll go into those functional groups and these things that get stuck onto the side. But notice if you have YL and it's got this F in front of it, it means it's a 2 carbon. If you have 1 carbon, it's going to be methyl. And if it's 3 carbons, it's propyl. And if it's 4 carbons, it's butyl. So we'll get into that more next time, okay? But I wanted to just go over alcohols a little bit right in here because this one's kind of an important one, okay? So you guys kind of seeing a trend here? This is where you guys are going to kind of see, but understanding these different functional groups and how this works is kind of important. Okay. Our next set here, switch colors, I can, is ether. So the next one here is ether. So you probably have heard of ethers. What does ethers look like? It's a carbon bonded to an oxygen bonded to another carbon. Ooh. So how does this look different than ethanol or alcohols? This oxygen here was bonded to a hydrogen, remember? Now if that oxygen is bonded to a carbon on either side, it's an ether. So an example of that would be CH3, CH2O, CH2, CH3. And these are referred to as, the functional group name is just ether. Okay? So we have our little functional group in the center here. So we have a carbon, oxygen, carbon. Here's our middle part of it. So we know it's an ether. And on either side, we have two carbon molecules, right? So when you have two carbons is F. So we know that. So we know that there's an ethyl group here. So this is an ethyl group. And this is an ethyl group because it's 2 carbons long. Remember, because the next thing you do is you count how long your carbons are. So on this side we have a 2 carbon, so it's ethyl stuck to another ethyl group over here, and we have this middle part of it in here is our, because we have got the carbon, oxygen, carbon, this is our ether bond. So we call this compound diethyl, because there's 2 di, di means 2 carbon groups stuck onto an ether. So if I wrote this word out, I would go with an ether group. Ether group means carbon, oxygen, carbon. I know there's 2 ethyl groups. Ethyl means 2 carbons stuck onto my functional group here. So this is diethyl ether. Okay. We're going to be going through a lot of these, not just today, but also next week, Monday and Wednesday, and then you guys will have a homework assignment where you guys are going to be practicing these things, and so you'll get the hang of this. So that's the next one. Okay. The next one we're going to do is aldehyde. Aldehydes. So what does an aldehyde look like? C double bond O connected to an H, and then you've got your 4 functional groups over here. So over here, you've got the carbon, oxygen, carbon bond. Here, your carbon is double bonded to an oxygen and then to a hydrogen, and double bonded to this. Now, this looks different than alcohol, right? Because alcohol was the carbon is bonded to an OH group. Here, the carbon is double bonded to an oxygen hydrogen. So this gives us our aldehydes here. So an example of this is CH3, C, double bonded OH. And the functional group name here is Al. That just means that it's an aldehyde. So we go back to the way we name things. We go, okay, what's the longest okay, our functional group is right here. So it's a carbon, carbon, double, so we know it's an all at the end. And then we count up the longest carbon chain, which is 2 carbons. So what is 2 carbons referred to as? Ethyl. So we could go this ethanol. So this is the ethyl group, because it's 2 carbs. We add that AN, so we could call this ethylol or ethanol. This is the same thing. So this AN in here, just to help make it sound better, because you can't go ethol, so it's ethanol or ethylol. So we know that this is our functional group, so we know it's an aldehyde. We know this, and then this tells us our longest carbon chain. Next ones are ketones. So ketones are C, C, C. So we have 3 C's. This middle one has that double bonded oxygen. So now this one has 1, 2, 3, 4 up, so this one's full. And then this one and this one can fit into anything else. So an aldehyde has that C double bonded O at the end. Here that C double bond is in the middle. So that's a ketone. The ketones end in O-N-E. So if I drew the basic one, now we do our same game again. We go, oh, what's our functional group here? Oh, I see a carbon, carbon, carbon with a double bonded oxygen into it. that must mean it's a ketone. Ketones end with O-N-E, so this must end with O-N-E. What's my longest carbon chain inside of here? Is 1, 2, 3. So this becomes, what's 3 carbons? 3 carbons is prop. So this becomes propanone. Propanone. Now, we don't use this word usually because this is a really hard word to say. So what we usually refer to this as acetone. Why? Who knows? Probably they figured out acetone before we had all this, like, this is called the IUPAC. Like, this is a standardized way we name things. So acetone's been around for a long time. What do we use acetone for? Like nail polish remover and stuff like that. So it's a really good solvent, right? We use it to, we can use it to dissolve nail polish. We can use it to dissolve paint and everything. So that's acetone. It does have that O-N-E at the end, so we know it's a ketone. All ketones have this carbon oxygen with this double bonded oxygen in the middle. Why we call it acetone? Who knows? It's just the common name. So this is what we call a common name. This is the IUPAC name. So this is like the official name for it. Actually, it's 2-propanate. So that's like the official name where it's like all official, but we usually go by the common name. Same thing kind of like when we were talking about the alcohols and stuff like that over here, and methanol and stuff, and we had all these different names for it. Well, the common name for this is ethanol, or alcohol, or ethanol. And we could call this methanol or methanol, so we have common names for things, and then we have the official name. And so this one right here, this is acetone. This is what acetone looks like. So it's a good solvent and stuff like that. And it's a ketone. And I don't think the ketone, isn't there some diet right now that's going on? Keto diet? I don't know if it's related to ketones at all. I don't know what. I'm assuming it is. What I'm assuming is that there's something with, I don't know anything about the diet. I'll have to look it up. But the keto diet, it has something related to these compounds and this ONE and this type of bond in there. And then they took that and they use it for something else. And we'll talk a little bit more about that, like saturated and unsaturated fats. The difference between them is a saturated fat is all single bonded. An unsaturated fat has a double bond into it. That's the difference. That's what a saturated versus unsaturated fat. This is saturated. That's unsaturated. It has a double bond in it. That's all the difference between them. So we're going to be kind of bringing up some words that you may hear in common language, like octanes, ethanols, acetones. So now you get a better appreciation for them. And then when we start talking over the next quite a few weeks, and we start talking about like what happens to acetone in the environment, you'll be able to look at this molecule by the next couple weeks, look at it and go, is it biodegradable or not? How will it migrate, and does it zorb onto carbon? So over the next month, you will get to the point where you're not going to like, what the hell is that compound anymore? You'll actually be able to look at it really quickly and know a whole bunch about its chemistry and understand how it moves and fades in the environment. So that is our goal over the next month. Right now, it is just hard. Like, I got to get you guys to understand some of these basics before I can move into some more of the fun stuff. Okay? So that is it for today. What we'll do is next time on Monday, we're going to continue on with what we're doing here. We're going to be going more into meaning of organic compounds and everything like that. If you want to review some of this stuff, your book, chapter number 7, has all of this in there. So I highly recommend you start looking at chapter 7 and reading that in conjunction with what I'm doing here in class. Okay? So I will see you all live on Friday.